So sorry, I just had my mic muted. But what can I help with?
Um, I don't really remember how to do the U-Substitution stuff,
Okay,
so I kind of just wanted to go over like the 5.5 thing that you sent me.
okay, sure. So you said you have a test and a quiz coming up. So is you substitution on that? In other words, would if we went through those questions, would that be helpful to your quiz or test?
Yeah, so the quiz tomorrow is some of the stuff that we already went over,
Uh huh.
and then the U-Substitution.
Okay. And for the quiz tomorrow, sorry, like on the other stuff that's not you sub, like do you have any questions or anything troubling you? Because I was happy with how you did on your last quiz, but I'm always happier with more. So like I want to make sure. Basically, I want to. There's between your ability to learn and my ability to teach, there's no reason that we should not be getting an A every single time, so like a solid A. So that's what I want. And so like ask me any questions if there are any questions that you are not sure about from the other stuff. Otherwise, U sub is very pretty easy. It's very predictable.
Yeah.
Go ahead.
Um, on the quiz, the only thing that I like did wrong was like um I got like 11 out of 12 from like most of them because
Mhm.
like I did some like one like arithmetic mistake or something like that.
Okay.
But then like there was like one question that I completely forgot was going to be on it. It was the from 5-1 like the area thing with like midpoint whatever.
Mm-hmm.
So I completely forgot how to like split the thing up.
Okay.
So I got like a 2 out of 12.
Okay. No problem. Um, yeah, and your teacher is like he's a great teacher, but he's not like a forgiving grader, so that's okay. All right. Um, sorry. Uh, Do you have the any of the questions on 5.5? I'm like looking at it on my phone, but if you have them, you could start shooting away.
Yeah, I have them. It's just like I just don't remember how to do U-Substitution.
No problem. Okay, sorry. Um, so like big picture when you're doing U substitution, we said like there are a bunch of rules of thumbs. All of them are like essentially a guess, whether you're an expert, an amateur at it, and like like you'll quickly see if if your guess is right. And so like I guess I could start with this question. So like this is just off the top of my head as I load, but like yeah. So suppose I give you this integral one over. This isn't like the very basic ones, but 1 over x ln x. It's not very hard either. So I give you this, and so there are general rule of thumbs, and one of them that we said is if you have a composition of functions inside the integral, that might not be everything that's inside the integral, but if there's a composition, you should let the inner function be u. That should be your first guess. But anyway, let's keep it focused. Let's start with this question. So you're guessing what you should be. What do you think you should be?
Isn't it usually the denominator?
Yeah, exactly. It's usually the denominator, and sometimes it's in part the denominator. Sometimes it's in whole the denominator. So here, shoot away. Like, what do you think I should make you?
X natural log of x.
Okay, so let's try that. If we let u equal x natural log of x, what's the next thing that we have to compute?
The derivative of that.
Yeah, exactly. And notice that when we take the derivative of that, what do we have to keep in mind in finding du?
Um, uh,
It's okay. So the u right now is a product of two functions, so we have to use the product rule. But then that's going to be like a giant thing. And what we said is like whatever is du should also be a part of your integral. And we already took like a chunk out of our integral and taking the denominator. So we see that our du is not going to show up in the denominator because our du is going to be some big thing. So yes, the one of the rule of thumbs is pick the denominator, but now we make a small adjustment, which is pick a part of the denominator. So what do you think?
Just natural log of x.
Yeah, exactly, and that will work. Because look, if we let u equal the natural log of x, then what's du?
1 over x.
Yeah, exactly, 1 over x dx. Now look, there are two ways to move forward. One is to reckon that, like, you know, your integral is 1 over the natural log of x times 1 over x dx, wherein it's immediately clear that this here is du and this is u. So then you could immediately write in your next step, if I continue in red, you could write, oh, this, what we have is 1 over u du. So that's one way to move forward. The other is like kind of the methodical way, which is once you take the derivative on both sides to find du, then isolate dx. So both ways are good ways to move forward. So whichever you find easier. So if we like a lot of the time, like you'll find, like, you know, isolating dx an easier way. So, you know, like let's move forward with that. So if we isolate dx from here, what should I write dx is?
Du times x.
Yeah, exactly, x times du. And now you're ready to rewrite the integral, and we're gonna get to the same places here, but a slightly longer path, and it's okay. So we get 1 over integral 1 over x, and then the natural log of x is u. Remember, we didn't come up with a substitution for that, but so you leave it alone, and it will take care of itself as soon as you make the substitution for dx. So dx is x du. So we go, oh yeah, x du. So then we go, this x now and this x cancel. So what we have is integral 1 over u du. Sorry, did you understand what I was talking about? Like, you know, writing it a bit separately there and seeing it as 1 over u du?
Yeah, I got that.
Okay, no worries. Either way is fine. And I think, like, you know, you're a very capable student, so you might be able to do. You will be able to do either. But just to play it safe, so we get 100. Like, do solve for dx after you find what du is in this step, in the second step, after you claim your u. Okay, so then let's finish though. What's the integral of 1 over u du?
So you put the natural log of x back in for u.
But now the entire integral is cast in terms of u. So just in terms of u, if we move forward, what's the integral of 1 over u du?
So natural log of u.
Exactly, natural log of u plus c. But then you call back what we said was u, which is natural log of x. So now it's natural log of x plus c. Yeah?
Yeah, I got that.
Okay, cool. So we kind of started, like, you know, not with the most straightforward, but it was intentional. So, you know, like the more basic ones, and this is kind of what I was talking about off the cuff earlier, are like the ones involving compositions of functions. So the composition is not your everything that you see, and it needn't to be, but, like, you know, if you have like something like this, so x to the 6th plus 2x plus 1 to the 5th. So here, what should u be?
Is it x to the 6th plus 2x plus 1?
Yeah, exactly. So just to save us some writing, I'll just circle it and call it u. Got it. Now, what's du?
6x to the 5th plus 2.
Yeah, 6x to the 5th plus 2 dx. Now, this is at this step where you need to check if you're going in the right direction. In other words, this here better be the rest of your integral, and maybe not exactly. You may see like a multiple of it. And yeah, what we have right here, I'll box it in green. What we have right here is a multiple of the right side of our du. It's multiplying the right side of our du by 1/2. And so you know now that you're in the right direction. You're going in the right path. And of course, like, if and your du, if you could do some factoring so as to get this here in exact form, then you should do that factoring. And what we need to do is factor out a 2, and then we'll be able to write 2 times 3x to the 5th plus 1 dx. Okay, and if we, stuck to our script, then the next step should be du over 2 times 3x to the 5th plus 1. And so then, now you come back and substitute everything. So talk to me.
So you have the integral of 3x to the 5th plus 1.
Mm-hmm.
And then times u to the 5th.
Yep.
And then times du over 2 times 3x to the 5th plus 1.
Yep, exactly. Beautiful. And of course, like, this is why you want to do the factoring in this from the second step to the third step, because now it's much easier to see, like, the exacts cancel. And so then what you have in the next step is integral u to the 5th du, and then over 2, but then that's 1/2. Take out any constants, u to the 5th if you can. And so that over 2 is really a 1/2, and that's what I'm saying. And so you have this. So now you have 1/2, and then you move forward from here.
You have 1/2 u to the 6th over 6.
Yes, exactly. Good job. Over 6, and then plus c, and the 1/2 and the dividing by 6 combine to a 12th, and then yeah, exactly. U is that thingy, so it's put it back in. So plus 1 to the 6th plus c. Fair?
Yeah.
Okay, cool. All right, so we're developing some some more like tools in our toolbox of like how to guess the u. And so I'll just go to the next example in the 5.5 slide that I sent you. So the next example is x cubed cosine x to the 4th plus 2. Okay, integral x cubed cosine x to the 4th plus 2. So now we said in the composition, like, take the inner function. Now, if the inner function comes with a constant, whether it's in the denominator or not, like, you should include the constant in your claim of u. So that what I said is not very precise. So I'll write down a problem right here and explain. Sorry. So if we have like 2x, let's say, over, and then it's the square root of like, sorry, hold on. 2x plus 1, the square root of like x squared plus x plus 5. Like, so now you have composition and stuff in the denominator, right? This is not a hard problem. I'll do it very quickly. What I just wrote in red. What I'm trying to say is like don't claim only this part to be u. It may be obvious, so I apologize if it's too obvious. But like, don't claim just this part to be u, the terms with x. If there's a constant, always include the constant in whatever you are going to say is u, because, well, when you take the derivative, the constant is just going to go away. So like u, this is u, what I just circled. Okay, fine. I'll do it very quick, as I said. So then du is going to be 2x plus 1 dx. So du over 2x plus 1 is equal to dx. So you come and go, oh yeah, this is integral. Well, so if we use the kind of more direct approach, notice that this here is what we have right there. That's exactly du. So you don't have to solve for dx, as I said earlier, if you just see it like that. So then if we, since this is just an extra problem we just made up, like, I'm just going to take that approach. So then the numerator is du. The denominator becomes the square root of, you could solve for dx, obviously, but like we don't have to. So we go like this. All right, so the next move is, oh yeah, this is integral, and then it's du over u to the 1/2. So that's integral u to the negative 1/2 du, and then that's u to the positive 1/2 over 1/2, which is multiplying by 2 plus c. Just call back what we said was u. But let's return to the task at hand and you talk. Go ahead.
Wait, if
Go ahead.
for the little thing that you just did,
Mm-hmm.
if you're solving for dx,
Mm-hmm.
and it's 2x plus 1 times dx, would you not subtract 2x?
Sorry, can you ask that again?
For the part where it's like du equals 2x plus 1 dx,
Mm-hmm.
do you not, wouldn't it be du minus 2x equals dx?
Oh, okay. So there's something that I was casual about there. Good question, and a lot of books do that also, which is, well, what's happening between the 2x plus 1 and the dx is multiplication. So technically, we would be dividing by 2x plus 1 as opposed to subtracting 2x. So the dx is not just multiplying the 1; it's also multiplying the 2x. So technically, there needs to be a parenthesis. It's just implicitly understood. Now. Yeah. So if you know what, one way to approach it is like, be like, yo, guys, like, look, 2x plus 1 dx, that's all in the numerator. That's exactly du. So that's why I wrote a du right there. So you could do that, or what we had done earlier, and I'll do it the way that we've been doing it. So you have this over, and then we see that it's square root of u, but then dx, if we solved for it right here in this step, would be du over 2x plus 1. So then, oh yeah, I'm going to replace this with du over 2x plus 1. I think you're more than answered your question, but sorry if, yeah, it was, but okay, unnecessary hand holding, but yeah, so, but the point is that it was multiplication that was happening, so technically what you need to do was divide.
Yeah, that makes sense.
Okay, sorry. And sorry. Okay, so let's return to the task at hand. Go ahead, help me out.
So u is x to the 4th plus 2.
Mm-hmm. And then?
And then du equals 4x to the 3rd.
Yep.
dx.
Yep.
Then dx equals du over 4x to the 3rd.
Yep.
And now it's the integral, right?
Yep.
Integral of x cubed cosine u.
Yep.
Times du over 4x cubed.
Yep, exactly. Uh-huh.
And then the cubes cancel out.
Yep.
So you're left with the integral of cosine u d 1/4 du.
Yep, throw the 1/4 in front, yep.
And then 1/4 integral 1/4 times the cosine of x to the 4th plus 2.
Wait, sorry, what's the integral of cosine of u?
Oh, sine.
Uh-huh, exactly.
Plus c. And then it's 1/4 sine x to the 4th plus 2.
Yep, exactly. Done. Mm-hmm.
So that's it.
Yep, exactly. So actually, I was ahead of myself in the denominator example that I was gonna do. Like, I'll keep. So, is your only question in this session for U-Substitution?
Yeah.
Okay, gotcha. So, I know what I'll do. Hold on. I'll integral x e to the x squared dx. The next couple are gonna feel very basic because you're very smart and yeah. Like, you know. Oh, I accidentally did one of the examples. That was the first one that we did. Okay, cool. So yeah, I'll do all the ones that are on this 5.5 handout, and then I'll do maybe one more of my own that will be like really fun, and then we'll conclude there. Okay, sorry. So basically, I have a plan. All right. So talk to me here.
Is u e to the x squared?
When you have e involved, make u only the exponent of e.
So x squared.
Yeah, exactly. And I mean, it's perfectly okay. Like, you know, at your stage, like, because you're learning this for the first time. I've been doing this for years. To claim it, and then like you'll find out immediately. Like du is going to be e to the x squared times 2x dx, and like since you claim this to be u, the rest of it, which is only x, is not going to match up with all of this. So you'll quickly find out if you've made the wrong choice of u, and it's but my point is it's okay to make the wrong choice of u. All right, go ahead.
So du equals 2x.
Exactly. So it's
then dx equals du over 2x.
Yep, du equals 2x dx. Yep, d over 2x equals dx. Go ahead.
And then the integral of x times e to the u.
Yep.
Times du over dx 2x.
Yep.
And then the x's cancel out.
Yep.
So then it's 2 times 1/2, yeah.
Mm-hmm.
Times the integral of e to the u.
Yep.
Du.
Mm-hmm.
And then that's 1/2 e to the x squared.
Yep.
Times 2x dx.
Mm-hmm. Well, sorry. So.
Oh, wait.
Go ahead.
Is that it?
Yeah, exactly. Because what you had left is 1/2 the integral of e to the u du. The integral of e to the u du is just e to the u. But then you put back the you wanted to do two things at once, and that was fine by me. And so that's where you found that. And so you just need your plus c. And Mr. Clark is like very serious about his plus c's, just as an FYI.
Yeah.
No, actually, I remember like years ago. This is years ago. Like I substituted for his class, and he gave an extra credit question, and the extra so this one super smart girl was like, "Oh, I didn't get the extra credit question," and it was all about like a plus c, basically. Sorry. So integral z squared over z cubed plus 1 dz. Talk to me.
So u is z cubed plus 1.
Exactly, and I like maybe labored too hard earlier, but this is what I was trying to tell you, which is it's tempting to just pick this, but if there's a constant attached, only a constant with the denominator, don't leave out the constant. Like we said, it's going to disappear. So there we are. Okay, go ahead. Du is?
3z squared.
Yeah, exactly. dz, yeah. And then solve for dz this time.
Then dz is du over 3z squared.
Yeah, exactly. So come back sub. So let me know if you have questions, but I'll just silently write because at this point I think you're good. Okay, where to from here?
And you get 1/3 natural log of u.
Yep.
Plus c, yeah. And then you get 1/3 natural log of z cubed plus 1.
Yep.
Plus c.
Yep. There you go. Beautiful. Okay.
Do you have to put the absolute value thing in?
Yes. Well, yeah. Yeah. You don't have to in certain things. Like, I mean, this is us, like, being very luxurious because I could just answer it by saying always put it on. But you don't have to put it on something like z squared plus 1, which is like x squared plus 1, because, well, x squared plus 1 is like this. It's always positive. So in things that are always positive, you don't have to put it there, because the whole point is that like the inside of the natural log cannot be negative. But instead of getting fancy like that, we could just say always put it on. It won't harm.
for natural logs.
Yes, exactly. Okay, so here we go. Next is tan x dx. So this one is a curious one because, well, it's not a composition. Basically there's very little to work with. It's not a composition, and there isn't anything in the denominator and yada yada. But so like if you have ideas, let me know. Otherwise, I'll hint you.
Can you make it sine x over
Yeah,
cosine?
exactly. Because then you'll introduce a denominator, and then you could use our rule of thumb. Beautiful, very well done. So sine x over cosine x. And so obviously I'm saying like if you get to cot, like that's cosine over sine. So for things like this, use this little strategy. And from here it's very simple because, well, now that we've introduced the denominator, we're going to be like, oh yeah, u is cos x. Du is the derivative of cos x. Remember, the derivative of cos x is negative sine x dx. So du over negative sine x equals dx. I know if I asked you to talk me over it, you'd be able to, but I want to like do our session super efficiently so that I could get to that one interesting question that I have in mind at the end. So that's why I'm talking as opposed to you. Sorry.
Okay.
Okay. So dx is du over negative sine x. Okay. And so then this and this will cancel. So you go, there's a negative right there, let's not forget. So we put that negative in front, and so we get 1 over u du. And so then that's negative the natural log of absolute value of u plus c. But then u is cos x. So pay attention in this part. I know you are always, but negative natural log of u is cos x plus c. But wait, there's that log rule. And that log rule said, like, if we have a, the natural log of b, then that's the same as the natural log of b to the power a. So technically, this is not just a negative sign, it's negative 1. So what we could do is use that log rule and be like, this is the natural log of absolute value of cosine of x to the negative 1 plus c. And that's the natural log of, well, that's 1 over cosine of x to the positive 1 plus c. But 1 over cosine is known as secant. So in our final answer, we go natural log of absolute value of sec x plus c.
All right.
Okay, cool. So, sorry. Yeah, example 6 we did at the start. Okay, so now like it's u sub together with limits of integration. So like integral of square root of 2x plus 1 from 0 to 4 dx.
We don't need. Do we need this plus c anymore?
No, we don't. Exactly. Great observation. Go ahead. So get me started here. What do you think?
Is it 2x plus 1?
Yeah, exactly. And u equals 2x plus 1. And here, like, what might surprise you is that there's nothing outside of it. And that's okay. We'll find out quickly that, like, as soon as we write du, that's because there's no more x on your du step. Du is just going to be 2dx. Talk to me from there.
Dx equals du over 2.
Yep.
And then the integral from 0 to 4.
Yeah, so that's let me help here. Now you also need to replace these because they were about x. Since we're about to switch to u, make them about u.
How do you make it about u?
No worries. Use this translation. Good question. Use this translation. Your claim of u.
Oh, so it's 5 and so 1 to 5.
Exactly. Beautiful. Very well done. 1 to 5, and then talk to me.
Square root of u.
Yep.
Times du over 2.
Yep.
Um, is there anything that cancels out?
No, it's okay, and it's okay. So we go 1/2, 1 to 5, and then we write so that we could use the power rule. We write u to the 1/2. Go from here.
Um, so then yes, it's 1/2 integral 1 to 5.
Well, you're ready for the integral. Go ahead.
Uh, um, u to the 3/2 over 2/3
Exactly. U to the
times 2/3.
exactly. I know what you meant. No worries. Times 2/3. You're like beyond good at the fundamentals. Good job. Okay, so 1 to 5. Okay, and so this two and that two cancel, and so then you get 1/3, and then it's the square root of u cubed evaluated from 1 to 5. Well, I'm sorry. Yeah, so u to the 3/2, we said one way to interpret it is exactly as I've written it, the square root of u cubed. What is another way that we said you could interpret it?
The whole thing is cubed.
Yeah, exactly. So we could be like the square root of u cubed, and one of them may be better than the other here. I don't know. We could just go with what I have. Okay, so it's 1/3. But yeah, basically like be flexible in that step is the whole point of why I brought it up. So 5 cubed is going to be 125. So we do that, and then minus 1/3 cube root of 1. Okay, so to simplify the cube root of the square root of 125, we could be like, oh yeah, that's the square root of 25 times 5, so that's 5 root 5. So if we do that, then we get 1/3. We can take out the 1/3 in front all the way from both of the terms, and then we get 5 root 5 minus 1. Let me know if you have questions.
That makes sense.
Okay, beautiful. You're like the easiest student to teach ever. No, seriously. Okay, so this one might be you get everything. Like the first time you're taught it, you're like super polite, super sweet. It's like, yeah, I wish every student was like this. I'd still be in the classroom teaching.
Do you not teach anymore?
I only tutor, and I have like another thing that I do, but I'm not in the classroom. Like my students like would love me in the beginning, and then like as the year draws, like they're not polite. Like they're not all polite. Like most of them are great, but I like after ninth year of teaching, I like lost the patience I used to have. Like so, I mean, this is kind of like a really silly, immature joke, but I'll tell it to you anyway. So I said to myself, like, I'll only get back in the classroom when you can punch some kids. No, really. um, okay, sorry. So go ahead, get us started here.
U is natural log of x.
Mm-hmm. Great way to like implement our earlier ideas. Yep, exactly. And you might as well, while you're here, change these guys also. Go ahead.
So du equals 1 over x dx.
Exactly.
And then dx equals du times x.
Yep, x du.
And then the integral from...
Yeah, exactly. So what do these guys change to?
Natural log of e.
Yep, which is
1.
Yep, and the other guy,
and then the natural log of e to the 4th.
which is
4.
Yeah, good, beautiful. Yeah, this is why I'm like so happy like that you're like so good at the fundamentals. Okay, great. Yes. So now it turns to 1 to 4. Talk to me.
So dx is x du.
Yep.
Over x times the square root of u.
Yep.
Um, do I replace? No, I don't. You don't replace the u's and the u yet, right?
No, not yet. After we finish the integral. Uh-huh.
So the integral from 4 to 1, no, 1 to 4.
I gotcha. Uh-huh.
How do you du over square root of
You got it. The only exception, right, like, is when we have 1 over, like, u or any variable to the first power. In that case, we have to just claim it as the natural log, right? But for all other ones, we could always use negative exponents so we can use the power rule. Add 1 to the power, blah, blah, blah.
So you could just rewrite it as du times u to the negative 1/2.
Exactly. You, like, skipped a step, which is fine, because I know you get it. But yeah, first, the square root of u turns into u to the 1/2, but when it comes upstairs, as you said, it will become u to the negative 1/2 du. Exactly. Go ahead.
And then you get u to the 1/2 times 2.
Yeah, exactly. Very well done. And then we don't have to go back to x because you already switched the e and e to the 4th into 1 and 4, so you could just evaluate from here. Talk to me.
So you got 2 times 1, so 2 minus 4 times, so 2 times 2, so 4.
But which one goes first? Which one do we put in first?
Oh, the top one. So 2 minus 2.
Yeah, 2 times square root of 4, and then it's okay, like 2 times, you got it, square root of 1. It's intentionally, because earlier I was talking you through this part, and maybe I didn't let you, give you an opportunity to perhaps, like, learn. So that's why I made you do it here. But yeah, like, I'll just reiterate, intentionally repeating myself, plug in the top, plug in the bottom, put a minus sign between them. Okay, so 4 minus 2. And I think you already said the correct answer. You're just, like, way ahead of me. Okay, cool. So there that is. And next is okay, this one. So this one is integral 0 to pi over 2 cos x sine of x. Yeah, like, don't get intimidated. Like, this is as easy as the rest of them. It just looks intimidating. Go ahead, talk to me.
U is sine x.
Yep. As we said before, like, if you have a composition, the composition is right here. Make the inside function the u, and then it will work out. Talk to me.
If you make u sine x, does that mean both of them are u?
No, because the outer sine x, it's not sine of x, it's sine of sine x.
Yeah.
Okay.
So it's just the inner part.
Exactly.
And then
Good question,
du equals cosine x dx.
Yep, exactly.
And dx equals du over cosine x.
Yep, dx equals du over cos x. Yep.
Then you have the integral from 0 to pi over 2. U is sine x, so the sine of 0 is 0.
Yep.
And then the sine of pi over 2 is 1.
Yep.
And then you have cosine x times the sine of u.
Yep.
Times du over cosine x.
Yep.
And the cosine x's cancel out.
Yep.
integral from 0 to 1 of is it cosine u?
Sorry. So we have this, and so we need the antiderivative of sine u. What is that? It's close. Cosine u is close.
Negative cosine?
Yeah, because the derivative of cosine is negative sine, so if there's no negative in front of the sine here and inside the integral, it must have meant that we took the derivative of negative cosine. Exactly. Okay, so negative cosine u evaluated from 0 to 1. Talk to me.
Then you got negative cosine of 0. Cosine of 1.
Yep.
Minus, no, plus the cosine of
exactly.
Cosine of 0.
Yeah, and cosine of 0 is?
Cosine of 0 is 1.
Yep.
And cosine of 1 is also 1.
We don't know cosine of 1. Like, we only know cosine of denominations of pi without a calculator. So cosine of 1 is like, you need a calculator. So your final answer here, you'll just write 1 minus cosine of 1.
Alright.
Okay. Alright, so the next couple, we only have like 2 more on 5.5, but they're like cumbersome more than hard. The last one I like because it will kind of give you a different variety. The next one is trivial. It's just it looks cumbersome. So sine inverse of, but it's still maybe worth it to remind you like your inverse sine derivatives and such. So 1 minus x squared dx. Okay, so talk to me.
Is u 1 minus x squared?
Usually, that is what we would go for at the denominator and so on. So perhaps this is a good example. So, you know, a rule of thumb is a general rule of thumb, not always, right? So this is a good way to recognize exceptions. So we pick our u based on like when we take du, is that derivative inside the integral except for maybe being multiplied by a constant? That's the big picture, like, takeaway in all of this. So if you think about that, then, like, there's, if I write this integral very explicitly, it's really this, right? 1 over the square root of 1 minus x squared times sine inverse of x. I'm probably doing more lecturing than I need to, but it's okay, bear with me. Which is that, like, you know, earlier in our example, x e to the x squared dx, now looking back, it must have been very easy for us to see that u has to be x squared. Why? Because du, the derivative, is 2x, and except for missing that constant, du is sitting right there for us. Just like that, here, if we, like, you know, be very explicit on what the integral actually is, we can see that, like, the derivative of sine inverse is what?
1 over radical.
Exactly. Sorry for interrupting. Exactly. So then, if I change this 1 into a 2, in other words, if there was a 2 inside our integral, basically it turns into like the same kind of problem that this was. Anyway, getting back. So now it should be u.
Is it the whole thing? 1 over radical 1 minus x squared?
It's okay. That's the derivative. So u should be sine inverse x. Yeah, it's okay. And then du is, you have to learn everything for a first time. You've never been exposed to a question like this. No big deal. Okay, so what's du?
1 over rad 1 minus x squared.
Yeah, exactly. So kind of jot this in your head as like, oh yeah, like usually the u is in the denominator, and it's like if it's a square root of in the denominator, it's the inside of that square root in the denominator, blah blah blah. Usually it's that. But if I see sine inverse, cosine inverse, now I have a flag. Okay, cool. So then so move forward from here.
dx equals du times radical 1 minus x squared.
Yep. Mm-hmm.
And then you have the integral from u is sine negative. So you have sine of 0.
Mm-hmm.
So zero from 0 to is it sine of pi over 3?
Sine, and you might be right. Like, let's see. So I think you're right. Yeah, because one. Oh yeah, that's right. That's right. Good job. Sorry. I thought it was pi over 4, but I think you're right. Because if this is pi over 6, 30, this is pi over 3, the triangle goes, how does it go? It's 1 root 3, 2. So sine inverse opposite over hypotenuse is pi over 6.
Pi over 6.
It's all good. It's all good. And so then move forward.
Of u over rad 1 minus x squared
Mm-hmm.
times du rad 1 minus x squared.
Mm-hmm.
The 1 minus x squared things cancel out.
Yeah, so sorry. This is very subtle note. I apologize if I'm being too picky. Like, there's such a thing as math grammar, so I heard you a couple of times say du times rad 1 minus x squared. He can't take off points for that, but write the rad 1 minus x squared first and then the du later. But it's okay, it's okay. That's just like really unnecessary note in fact. Okay, alright. So next we go, it's math syntax. 0 to pi over 6, and then talk to me.
So it's u times du.
Yep.
Which is u squared.
Yep. U squared over.
So times 1/2.
Yeah, u squared over 2 exactly. Evaluated from 0 to pi over 6. So this is going to be like a weird answer, but go ahead.
So pi over 6 squared over 2.
Yep. Excellent.
Minus 0.
Yep. So that's pi squared over 36 over 2 minus 0. That's pi squared over 72. Fair?
Yeah.
Okay. So actually, Bud, I'm going to abandon the really fun question. So basically, you have to do U-substitution twice and the fun question that I had in mind. And it's just like for entertainment that we would be doing that. You'd never get a question like that. So instead, I'm going to make up a question similar to this one right now and ask you to do the made-up question because that's more targeted and helpful to your quiz. The goal that we're trying to accomplish. So 0 to pi over 2, and then arctan 2 arctan x over 1 plus x squared dx. So do this one. What's another name for arctan?
Inverse tan.
Exactly. Arctan x is equal to sine inverse. Sorry, tan inverse, my bad. I misspoke. And then, talk to me.
Is u still 1 over 1 plus x squared?
Like, use a similar strategy to the question that we had just done.
Oh, okay. So you can rewrite it as the integral from 0 to pi over 6. Inverse tangent x times 2 over 1 plus x squared.
Sure. Now, so like the whole point of us like seeing it this way, right, is to identify that the derivative of arctan is actually in there. So, and I'm pretty sure you might take like a math course in college, but like arctan and its derivative are like math people's favorite. So there's a chance that Mr. Clark might like put it on there. What's the derivative of arctan?
1 over 1 plus x squared.
Exactly. So that's why usually we pick the u to be the denominator. But this too, just like the last problem, is an exception because, well, the derivative of the tangent inverse function is in there for us. And that's why there is a denominator. Okay, so talk to me.
So u is going to be the inverse tangent of x.
Exactly, tan inverse x. And I will talk through this really quickly so that we can get to the next problem, and we will be able to anyway, but I want to do it efficiently. So u equals tan inverse, so du equals 1 over 1 plus x squared dx. So 1 plus x squared du is equal to dx. Actually, you carry on from here.
So you have the integral from inverse tangent of 0 of pi over 2.
Yeah, tangent inverse of 0 is 0.
Is 0. And then tangent inverse of pi over 6.
Yeah, I made a mistake there. It's pi. I can't have. I mean, I can. I'll just make it a hard problem. Like the numerator, I meant to be like 1.
Of pi over 4 then.
Yeah, exactly. That's what happens when you make up a question. Sorry. Go ahead.
And then you have 2 times u.
Yep.
Over 1 plus x squared.
Yep.
Times 1 plus x squared du.
Yep. And then
the 1 plus x squared is canceled out.
Exactly. Beautiful.
And then 0 to pi over 4. 2u du.
Yep.
So you have just going to be u squared.
Yep, exactly. U squared. And no over 2, you're right. Just u squared.
And then pi, to evaluate from pi, 0 to pi over 4.
Yeah, I trust that you can handle it from here, so we could just abandon this question right here. Okay. So, finalement, the last one. Do you take a language? Sorry.
I finished language last year.
What did you do?
Chinese.
Oh, cool. You didn't grow up speaking it.
It was my first language, and I forgot everything by the time I was 5.
Okay. Yeah. That happens. No, like I had a number of like American students when I was there, like that were taking Chinese. I think like, given how like, China's like prospered so much, like, and will be like a big player in the world, like it's like a wise choice. Yeah. I like learned French, but like, yeah, I don't know anything. I'm like good at accents, so I like know a couple of phrases that make me sound like an expert, but I like have no clue what I'm talking about. Sine x over 1 plus cosine squared x dx. Talk to me.
Is u 1 plus cosine squared x?
Let's see. Yes. For some reason, I thought it should just be no. But like so I'll write a similar question. So check this out. So like if it was sine x over 1 plus cos x, then that's correct. But because if you let u equal 1 plus cos x, right, then like du is just going to be negative sine x. Yeah, the negative isn't present in the numerator. That's okay. That's not a big deal. We said you can have constant multiples, right? So that's fine. But right here, it's not simply cos x. It's cosine squared. So I'll proceed with your choice of u, but let me show you what happens. So we have 1 plus, like technically cosine squared is like cos x squared. So then that's what we're claiming is u. You did well to go to look in the denominator. That's definitely the right choice. But then du is going to be like 1 plus 2 cos x, and then by chain rule times negative sine x. We don't have all of that in the numerator. That's too much for our numerator. So again, the difference is like this question right here that I just wrote and this question are very, very similar. The only difference is that cosine is not squared there and the cosine is squared here. When it's not squared, including the constant with your pick of u, that was a wise choice. But because it's squared, we need to think again. And I think you'll get it. Like you'll make the right pick this second time. And again, no big deal. And it's obviously the last question on this page intentionally, like because it's the most interesting, right? So what we're gonna do is we're gonna rewrite this cosine to make it clearer as cosine x squared. And now actually you can apply two rules of thumbs, right? One is look in the denominator. Two is look for a composition. So what did we say? If you have, because technically cosine squared is a composition. It's a composition of cosine and x squared. And so in compositions, what did we say?
Take the inner function.
Exactly. So what should u be here?
Cosine x.
Exactly. And then you'll see tan inverse somehow magically show up in this problem. But anyway, let's move forward and we'll get there when we do. Go ahead. So what's du?
Negative sine x.
Mm-hmm. Exactly. Yeah. Sorry, go ahead.
And dx equals du over negative sine x.
Exactly.
And then the integral for cosine 2 pi 1 and 5 over 2. So it's just and 0.
Yes, excellent. I'm so like happy with like how well you know your trick. Excellent. 1 and 0.
Is this gonna be a negative answer then?
Oh yeah, but we could do it. We could actually use the negative to cancel a negative that's gonna show up. But anyway, sorry, go ahead. It's gonna be positive in the end, I think. But go ahead.
So you have sine x over 1 plus u squared.
Yep.
And then
good observation. Sorry, go ahead.
du over negative sine x.
Yeah. Excellent. Okay. So so check this out, bud. So first, this negative, right? I can put a positive right there and put it in front of the integral, right? But then remember, the integral from a to b of some function f dx is equal to the negative of the integral from b to a of the same function. In other words, we can swap the limits of integration so long as we put a negative in front of the integral. But wait, we already had a negative from the sign. So when I swap, it's going to turn into a positive. Well, not at that step. On the next step, positive integral from 0 to 1, because we always want that smaller number to be at the bottom, at the lower limit of integration. And this sign obviously cancels that sign. And this is why I was able to see that tan inverse is going to be involved. So with that clue, how do we move forward?
And you have tan inverse.
Yeah, tan inverse of?
U.
Exactly. And I wasn't kidding, but when I said like tan inverse is like, and the derivative, whether you're like moving forward as a derivative or moving backward, which is as an integral, they're like math people's favorite. I guess it's because it's clean. It's nice. Like it's just 1 over 1 plus x squared or u squared, whatever variable you're using. So look out for that. Like as you're looking at problems like these, especially if you have like 1 plus something squared. If you have 1 plus something squared in the denominator, anticipate tan inverse being involved somewhere down the line. But You did a beautiful job. And so we move forward. So you have tan inverse of 1 minus tan inverse of 0. Just as a reminder, it's fine. Tan inverse of 0 is 0, but you're the one who told me what tan inverse of 1 was earlier. Pi over 4. So our final answer, pi over 4. Fair?
Yep.
Okay, cool. Yeah, so like the that really fancy cool problem, like someday if we have like you know, for if we have a downtime, I'll show it to you, or maybe outside of our tutoring time, but it wasn't gonna be anything. It was gonna be extra, as you teenagers like to say. So yeah, we'll end here unless you have other questions.
I think that's all.
Okay, all right. Have a wonderful night and get 100. Okay.
I'll get 100.
Okay. All right, bud. Have a wonderful night.
You too. Thank you.
You're very welcome. You're amazing and easy to work with.
Thank you.